Good evening and welcome to call. We appreciate your presence in today's class. We are going to kickstart from where we stopped in the previous class of day 5. This is day 6 over day 18. So we have 12 days to go. In this day 6, we are going to discuss more on statistical analysis. We are using statistical functions and formulas in order to derive data-driven decisions and relevant conclusions. So far, we have used analysis of statistics to deduce the mean of the age, hours of study, and exam score. We've also used it to understand the measure of dispersion around the mean for both age, hour of study, and exam score. The same thing also happens on the other analysis of data we have on the dummy data, where we saw how we can use the mean to get the average of salary of every staff and also the standard deviation of every staff salary. We also have seen how we can actually utilize formulas which are made up of operators to achieve a certain goal, such as the average, the sum of one or two variables. Today's class, we are going to look into regression analysis and hypothesis testing. And the two of them works together because we are going to, first of all, determine the hypothesis before we even talk about a test that we can use to achieve such hypothesis. Evidently, it is not only regression that can be used to solve hypothetical questions. Some tests of hypothesis also includes the chi-square tests. It also includes the correlation. Sorry, not the correlation. Permit me to remember that analysis. The analysis of variance, and so on and so forth. But the most popularly known tests of hypothesis are the chi-square, the regression, and the ANOVA. This is aside every other test of hypothesis we have in statistical analysis, such as the logistics analysis, the linear programming, and time series forecasting. All these are parts of statistical analysis that can be used for prediction, data science, and machine learning. So what should or can be the kind of hypothesis we can run on this particular data set of students? Remember that if you are to use regression, you need to have what is called the null hypothesis. So let's open to sheet 2, where you are using to express ourselves in what we are discussing. The null hypothesis. And this null hypothesis is a wonderful hypothesis that helps every individual who's a data analyst or data scientist to actually work on data regarding educational, health, economies, and other industries of choice. So this is null hypothesis, and this is alternative hypothesis or alternate hypothesis, depending on the text you are working on. So let me use alternates instead of alternative. So alternate is the main. What is the null hypothesis, you may ask? The null hypothesis is the original claim of a proposition. Original claim of a proposition. What do you mean by that? When someone originally claims that something exists or something does not exist, that is a null hypothesis. So the moment you say anything that comes your way at first glance, it is assumed to be a null hypothesis. And that null hypothesis is on a standby until it is proven to be true. Until it is proven to be true, we can then say we are going to accept it or reject it. This null hypothesis is represented by the arithmetic value H0. So far, so good. If you go to some texts or if you have read your readings, you will see all these I'm talking about come to play. You're reading some statistical analysis expresses and tells us how important you should understand all these tests we are discussing. Remember, we encourage you to always read your readings, as it's a good fit for you to understand better in what we are discussing so far in our lessons. Now, this alternate hypothesis, null hypothesis, is represented by a symbol H naught, right? While the alternate hypothesis is represented by a symbol H1, right? Now, these two hypotheses are the hypotheses that we use every statistical test, such as regression, I mentioned before, chi-square, I mentioned before, time series, and thereafter. And what do they test? They test the claims we have on a particular data. And that claim might be that this is existing or this does not exist. This is existing or this does not exist. That might be the claim that they are testing. So in regard of this, our particular data which we have here, we are going to decide which particular parameters we are going to focus on while looking at for a regression analysis. And from what we know, statistical analysis depends on numerical data sets or quantitative data, either discrete or continuous. Hence, our focus column for this particular test will be the hours of study and exam score. This is one of the most popular dummy data you can ever think of, right? Hours of study and exam score. Since we want to run a regression analysis, I want to see how the hours of study affects the exam score. And you might want to answer the question that says, does the hours of study affect hedge notes? So affect exam score? That might be the question you might want to ask. And the null hypothesis that accompanies it is hours of study does not affect exam score. So let me write down the null hypothesis we have, which we are going to state in order to run this regression analysis. So let me draw like a bracket line that links up this guy and this guy. So the null hypothesis, which is H naught, just as we've seen, is that the hours of study does not affect exam score. While the alternate hypothesis, which is H1, is that the hours of study affects exam score. Now, you might be familiar with this kind of statement if you're a statistics student, and I know that Francis is familiar with this. Now, the null hypothesis always follows the trajectory of questions or phrases such as does not, didn't, did not, is not, and so on and so forth. Why the alternate hypothesis follows the phrases does, did, and is. So when I was starting out in analysis of data as a data scientist or data analyst, as the case may be, I always wanted to understand how to figure out these two personas. And the reason is because they all look alike and sound the same. But with constant practice and clear understanding and research, I came to understand how best to handle the two of them. And that has been a good fit for them. So what worked for me might not necessarily work for you, but we believe that the aim of everything is that we will all be able to discern what we are talking about and also achieve the results we are looking for. All right. Then when you are dealing with this hypothesis you are working with as an analyst, you tend not to make any mistake. You tend not to make any mistake. And that mistake can occur as an error. That mistake can occur as an error. That is why we have at least two major mistakes that people do make in analysis. One of them is called a type 1 error. The other one is called a type 2 error. So when is it possible that an individual makes a type 1 error or a type 2 error? Well, let us carefully highlight the situations that can occur when an individual makes an error when it comes to using the hypothesis test. So I'm thinking of types of errors. Sorry, I'm having cough. So you have the type 1 error, and we have the type 2 error. What's the type 1 error? The moment you do not reject, so when an analyst do not reject the null hypothesis, that's H0, he has done what is called a type 1 error. So when analysts do not reject H0, he has, okay, I think let me paraphrase this very well. When an analyst does not reject H0, when H0 is false. Yes. Why here is when an analyst rejects the H0 when it is true. So you see, the situations is very, very critical. An analyst can reject H0 and can accept or do not reject H0. So when an analyst do not reject H0, when H0 is false, that analyst have done what is called a type 1 error. Now, what do we mean? We can say that, okay, after the analysis we are doing now, we find out that, oh, H0 is really false. That means we should have rejected it. But we didn't run the analysis very well, and we ended up accepting or not rejecting it. We have conducted what is called a type 1 error. But when an analyst is running an analysis, the hypothesis needs to be accepted, and he rejects it, then he has what is called type 2 error. So these kind of errors can happen in your areas of analysis because sometimes you might think that this is the right approach to solving the statistical problem, but at the end of the day, it is not. The reason is because some analysts tend to not understand the right parameters to be used for a particular solution. So you are trying to solve a problem with the regression and you couldn't properly identify your dependent variable and independent variable. There is a big problem. Or you're running a chi-square analysis and you couldn't identify your observation from your expectation. Or maybe you did an error in calculating your expectations. Then there is a problem. Or maybe you're running a logistics regression analysis and your variables or parameters of place are not binary. Then there is a problem. So when an analyst, do not carefully and extensively conduct his research on time, taking all parameters on check, and he ends up using the parameters for analysis, he is likely to conduct a type 1 error or a type 2 error. So we want to make sure that we do not fall in either of these situations. That is the best approach to solving any hypothetical analysis. Obviously, most statistical analysis we have in the world are all hypothetical in nature. That's why we call it assumption. So we assume that something like this happens until it is being proven with a statistical test. Then we can infer our conclusions and recommendations. In analysis of hypothesis 2, we also make use of what is called the alpha the alpha. So let me go to our scribble sheet. Alpha. Let me draw it. The alpha. Something like this. In some tests, you see something like this too. So it all depends on how the test arrange its content. So alpha is always at 0.05, or sometimes it will be at 5%, as the case may be. Right? And this alpha helps us to understand the limits of our accepting the hedge node or rejecting the hedge node, which is also accompanied with what we call probability value. That's the P value, probability value. Now, this probability value is a unit, a value that helps you to either reject or accept hedge nodes. So these two work in hand together that will achieve our purpose of analysis. Without these two working hand together, the purpose of analysis with hypothesis is not clearly achieved. And that is why no wonder every test of analysis comes with their own text of confidence, such as the t-test, the confidence interval, the confidence limits, and the confidence levels. These are the things that you must put on check for you to be properly sure and guided in your analysis as a data analyst. Remember, we said that data analyst performs 4 types of analysis in their project depending on the objective, and they include descriptive, diagnostics, predictive, and prescriptive analysis, which we double down to extract from the statistical analysis, such as the causal or exploratory data analysis. And while you are trying to find out information from your data, you are exploring. So EDA is not necessarily a particular formula or function. Rather, it is the action you take while trying to find out the events that happened in your data, just like we discussed when we introduced us to statistical analysis. Now, all this we are talking about in this particular concept of analysis is important for you to know. It is very important for you to know as a data analyst how all of these play a role in you deciding how to give your wonderful conclusions from the numbers you have gotten. Now, that is for hypothesis testing, which will help us to use the other tests of hypothesis I mentioned, and the most critical one that everybody uses in statistical analysis is the regression. Now, what is a regression analysis? If you have read the readings, you understand that regression analysis is a test of hypothesis or statistical test, which is used to model the relationship between two or more variables. And this relationship must occur between one that is a dependent variable or the other that's an independent variable. So you are likely to have one dependent variable and many independent variables. So analysis of regression, we must have 2 variables. So 2 variables must be there for us to actually conduct a regression analysis. So the first variable is the dependent variable. Second variable is the independent variable. And so far, so good. We always denote these particular variables with the letters y and x. So you see that y is the dependent variable, yx independent variable. Very, very easy to understand. So when we now have these singular variables, dependent and independent, then we call them a simple linear regression. So I'm going to use simple LR to denote it as simple linear regression. Then when we now have more than one independent variable, so in the situation where you have something like a dependent variable, y, variable y, and then, sorry, hold on, dependent variable y, and then we have an independent variables x1 and x2 and x3, so on and so forth. We now call it multiple linear regression, right? Because now we are having more than one dependent variables, but one dependent variable. But in a situation whereby you have more than one dependent variable, we can now use the word composites, but we prefer to continue with just multiple linear regression. So all these are what we put on check while dealing with regression analysis, and they help us, the analysts, to understand what has happened, what will happen, and how best to draw conclusions from that which has happened. Without understanding the role they play, it will be very hard for us to discern how best to draw our conclusions. So the formula that follows a regression analysis is very simple, because we say that it is a test of analysis, hence it will follow a certain formula. The formula is denoted by this I'm going to write down here, which is y, or yi, because we assume that I is number of events or observations. It's equal to, and we say b naught, that's the intercepts, plus b I x I plus e I. I, in this regard, stands for the number of observations we have in the data. And for what we are using in our analysis, we have 20. That's from row 2 to row 21. They are all 20. So the i's represents the number of rows we have at our jurisdiction, which is row 20 rows. So that's what the I represents. So I can type it down here. I can write it down with the cursor of normal. So they say that the I's stands for, the I's are the number of observations. So in regression analysis, you can use observations, or you use the word rows, as the case may be. Y is that smaller than y, yi is the various, is the independent, sorry, the dependent variable. Y is the dependent variable, as the case may be. Then b naught, we say is the intercepts. Y, b1, we say is the slope. Then ei, we say is the error residual, is the error or the residual. So I like putting them to the error residual, as the case might be. So this is a simple formula for regression analysis. Some text, you can see something like this. In some texts, you can see something like y I, not yi, just y equal to a plus b x plus alpha. So depending on the text you are using for your reading, but for the text I gave us, I still specify this and not specify this as well, to differentiate some labels that might be relevant for the analysis. So having understood this, let us now look into how we can use what we've understood from this particular concept we have digested to solving the problem we have at hand. So the problem we have at hand is the first hypothesis. You say hours of study does not affect exam score. The second says the hours of study affects exam score. But you might ask, there is no place in Excel that can help us to run this analysis. Because if you look at this, there's no default button on the ribbons to click in order for us to get what we want. Even if we say, let's go to more functions in statistical, and we say we want to do regression, let's try to get a function for regression. You will notice that it is not existing. Are you seeing that there's no regression here? So there's no regression in quotes on this particular analysis. So how do we, let me share the entire screen so that we can see it clearly. I don't want any issues to occur here. So if you look at it, now if you go to statistical, you can notice there is no function that says it is for regression here. But you can see functions for F distribution, F test, Fisher inverse, forecasting, like time series forecasting linear forecasting with the statistical. That's your normal time series forecasting. Then seasonality. If you have studied about time series very well, that's what's called seasonality. And then here we also have other time series forecasting functions. But there's something like regression function in this particular test of analysis in statistics. So how do we get it done? But we can see probability, which is this man over here, where we find the probability of a data of value between the two limits that are existing. And we have a Poisson distribution, which helps to determine some wonderful some wonderful events that happens in our data set. Then we have the permutation and combination. We also do not have I think when I was studying about data science, I loved using Poisson because Poisson is focusing more on the rareness of events happening. So how rare can this happen? That when you use the Poisson, which is stated with lambda, as the case may be. So there's a lot of statistical functions here, even Pearson correlation and the rest of them. We want to find the moments of correlation between data points. In probability, there's what is called moments. You have the first moment, the second moment, the third moment, even the 10th moment. So when you're trying to find the Pearson correlation between those moments, you can use this function of Pearson product correlation, where you find the moment of correlation coefficient R, as the case may be. And remember, in some statistical tests, there's what is called the Pearson man. Hence, this man is the one that introduced this Pearson product moment correlation. So if you have gone through data science courses, or maybe have tried to peep into what it's all about, you notice that these distributions are always used for data science analysis and data science projects, where you see yourself working with distributions in statistics to understand what happened in your data set and how you can use it to solve problems at the end of the day. So this has helped a lot of persons in data engineering sector, data scientist sector, database management sector, and other sectors, to name a few, which are always analyzed in the financial industries, economics industry, agricultural industry, which is the most used industry. The agricultural industry is the most used industry, where we use this more of these statistical functions. Yes, I have engaged in an activity that involves me using these distributions for analysis. So you notice a lot of things that you can do with Excel, even without you trying to go through SS or R programming or MATLAB. So let's see how we can make it possible for us to have regression in our Excel worksheet. To do that, we need to set up this Excel in quote setup. Now, what do you mean by that? Notice that there are some things, like I told us, my Excel contains your own, does not contain, I customize it to look this way, and that is very wonderful. If you notice here on the end point of the ribbon from Formulas tab, you can see an Anaconda extension, which is always on my Excel. So if I want to work on an analysis that requires me to use a Py script directly inside Excel, use this extension for Anaconda in my Excel as it stands now, right? Then if I still go to my data tab, I will also see, so my home tab, I will also see other extensions I have which can be used for analysis if I don't want to start installing so much of products, because most times you see yourself in so much project that you might even see yourself having more than 3 data analysis software in your PC. Yes, I have up to 5 analysis software, including SPS and Lingo. But I tend to harness the abilities of Excel since I can actually add extensions to it. And that's why you see Python here, which is extended into it. And you also see the autopilot, the other 2-pack I have, as the case may be. So how do we then insert regression into our system in Excel? To do that, we go to the data tab. Now, I'm trying to get us to see this. Look at this, data analysis and solver. Data analysis and solver. So if you're with your laptop, you will notice whether you have this or not. If you don't have this, then don't panic. You have to launch it into Excel. It is a default add-in in Excel. They are unlike these ones here. So these ones here on the home tab can only work when I'm connected to the internet. All right, because they are external extensions which read from external files. But the one on the data tab on the last part of the ribbon is a default extension or add-in, which also has base inside of Excel. All right. So this data analysis is a tool that we use for any statistical analysis. Most times, if you notice, if you just start watching from now going forward, that most Excel analysts rarely go to Formulas tab when they want to use statistical analysis, because they know that easy peasy, they can get all the analysis of choice inside the data analysis toolbar, which is what you are seeing here. All right, so what you are seeing here, data analysis. Why the solver is used for a linear programming analysis. So linear programming analysis, so what if, right? So how do you, one of the sweetest subjects or course I have taken in data science under linear programming is the integer programming, followed by the dynamic programming, and I think another one that is most commonly used is simple. I've forgotten that word, simple something something. So that was back then, right? So all these languages we studied in data science courses are also used in Excel. Open the solver by activating it. It will give you some boxes to impute your parameters of choice, where you try to model the relationship. In those days, when we were trying to solve it by hand, we tried to think of how you can iterate particular movements to get what you want. But because I learned to use a system to do that, it's easy for me to insert any model of choice, and then it iterates what the maximum and minimum, etc., etc. So all these are what we do in Excel, which is why most times you see a lot of persons also working with Excel, although their job title is data scientist. So now, if you don't have this solver and data analysis in your Excel worksheet, easily add it by going to the File menu. And go to the File menu, you go to Options. This direction is also in your reading if you have read it too, under the digesting data analysis, that PDF on digesting data analysis. If you go to your options, the options in Excel, you hover straight to add-ins, straight to the add-ins. Now notice what I have here. I have this add-ins active: analysis 2-pack, analysis video, XML dates, video to and solver add-in. These are all active for me. That's why you see them while we are discussing them in the solver. But these ones are inactive at the moment. Power Pivot for Excel, Power Map for Excel, Data Streamer for Excel, Action Pane for Excel, Inquire for Excel, PDF Maker for Excel. I can still click on them to make them active. But for you who does not have it active or inside this active add-ins box, what do? You go to this manage box. There is Excel add-ins, which you can click to see both COM add-ins, Actions add-ins, XML add-ins, and disable items. So if you click on the Excel add-ins first, which is the first one you're concerned about, and click on go, you notice that you have to check all these boxes. So mine is all checked because I already have them intact. So we must check all the boxes. Your own can come out 3, it might come out 4, like mine. And once you're done, you click OK. It will run the add-in for you. Now we come back to the data tab, you will see these 2 items available for you. Then if you still want to add other add-ins of choice, you still go back to file options, the add-ins, and click on the next add-in, COM add-ins, and then click on go. But let's say now this one add-ins, notice that all of them are all unchecked. That is how your first Excel add-in will be if you have not done them before. So I have to click here, click here, click here, click here, click here, in order to install these add-ins inside our Excel spreadsheet whenever we load Excel workbook. So we click on OK. It will take time to load a while. We went on your system speed, and look at mine, it's loaded easily. Now I have the data streamer tab, I have the Inquire tab, I have the Acrobat tab, that's to convert to PDF. I have the Power Pivot tab, which is also wonderful to use Power Pivot to model data in Microsoft Excel. So these are the 4 extensions, 1, 2, 3, 4, which I have installed add-ins into my Excel workbook. Now the 5th one is the create PDF. That's what you see here now, create PDF. So that there are 5 boxes I checked. This is a PDF creator, then data streamer, Inquire, Acrobat, and Power Pivot. If I still go back to the file menu again and click on more, now because I've installed those COM add-ins, I have to see my home view turned to be this way. Before it wasn't this way, so now it's not this way, and now I have to click on more to see options. But before I had account and options here. Due to installing those COM add-ins, I have to battle with space regarding the save as PDF, print, share as PDF link, and export. That's by the way. So come back to more options, add-ins, then go to the next one. Now notice that once there's no longer more than enough add-ins that are inactive. This one is the last one left. But other 2 are inactive, had all been added because I checked all those boxes for the COM add-in, right? So now to install this guy to come up, I can just go to the next add-in, which is the XML expansion packs. As you can see here, this is XML expansion packs. So I click on XML expansion packs, click on go. Then look at that one that is disabled. I click on it, and click on attach, right? And add. Okay, I don't have anyone to add yet. It's only attach I will do. So I click on it and then click OK. So I do that, I will have the XML expansion pack ready for me here. Now, what we use this to do, most times you want to open some query sections, some pivot sections, some panes in your Excel, which will just resemble what we have here. So the XML expansion pack helps you to expand your packs of data values and variables, which can be in panes when it comes to Excel. So these are the 3 major add-ins you must have in your Excel worksheets to be readily equipped for analyzing data with Excel. And also see the last one, which is actions. Click on go. I don't think we need, this one is already there, so we don't need to actually go along with it. So all of this we are done now. We actually have set this spreadsheet up for wonderful analysis we can perform with statistical and other functions we can think of in Excel. Now with this, now we are ready to start putting up our regression values. Now for us to do that, let's come back to the data pane, data tab, sorry. And let's look up to the data analysis and solver. All right. So we are going to click on data analysis because this is a go-to for anything statistical analysis aside go to the formulas tab. So this particular analysis here contains more of the things that you will not see in formulas tab or function library, as the case may be. And it contains 19 statistical texts relevant for your study projects or anything you want to work on, be it in any industry of choice. For the fact is, statistical analysis, you have to go. And here you can find regression. Look at it here. You can find regression here. And you can find other analysis of interest like moving average for time series forecasting, random number generation, rank and percentile, sampling, t-test for two sample paired means, t-test for two sample unequal variances, and t-test two samples unequal variances, z-test two sample variances, histogram, Fourier analysis, f-test two sample variances, exponential smoothing for time series 2, descriptive analysis of statistics, covariance, correlation, ANOVA two-factor with replication and without replication, and also ANOVA single factor. So you see, those things that data scientists do, you can actually do it in your data analysis tool using Excel. Very wonderful, right? So now I'll click on regression and then click on OK. With the OK being clicked, Excel will ask me which particular range of cell is my y-axis and which one is my x-axis. So let's come up to the data set itself, which is here. So let's tell Excel which one is our dependent variable and what's our independent variable. You said that dependent variable is the variable that depends or draws its source from the standalone variable. And the standalone variable is what we call the independent variable, that nothing can shake it and cause it to stutter. Even though the universe wants to shake, it will not shake because it's very independent. And in our case here, in this particular data set of student studies, the y-axis or the y-range per se is the dependent variable. What depends on what? What depends on what? So notice that hours of study can be an independent variable for your exam score. Because what you are looking at here, so a person studied less hour tend to score less in exam. Some studied more to score more in exam. Why those? Just like that's a variation of what you are seeing. So that means that the hours of study is an independent variable and should be on the X range. While the exam score is the dependent variable, which will be on the what? Y range. So for our Y range now, we click inside the box, making sure that this box is active and blinking very well, and so that we don't make mistake in our choice of range. And we said that range is the column or cells that contain the data set. And in this case now, since we are talking about statistical analysis, we are focusing more on numerical values. Hence, we are going to come over here and select this range by default, or we can type it in ourselves. So my own best practice is to just select all the cells of interest, and we have it here, C2 to C21, all here. Then I'll put in my X range. My X range is I've done mistake. C2 to C21 is our X range, which is our independent variable, while our dependent variable is the D range. That's the D2 to D21 under repeat Y range. So I'm going to highlight the D range. Yeah. So the exam score is our dependent variable, while the X score, S, which is hours of study, is our independent variable. Now, having understood this, remember we said that when you understand that, to help you to avoid making a type 1 error or a type 2 error. So I need to check all the boxes that is required of us. So the next thing is to check the boxes. So we need to actually highlight from D, D1 and C1 because we want to make sure that when Excel is analyzing this, it does not remove any variable Right? So let us reselect our range of cells. For Y now, I'm going to select from D1 to D21. Then for X range, I'm selecting from C1 to C21. Now, once at the end of this analysis, Excel will return the column name for me as the parameter column I have used. That is what I want to start from D1. If you must start from D1, which bears the column name, it means Excel calculation start from the C2, which bears the numerical variables. But if you start from C2, Excel will overlook the value in C2 cell and start with C3 cell. So you don't want to remove this man from your analysis because that will cause a biasness in the results. Hence, we are going to choose from the column that's down to the last of the values in the column of choice, and then tick this place that has the bottom labels. So click on the labels. You can accept that if you come to column C1 and D1, they are headers. But from these two down to D21, and from this C2 down to C21, they are all values you can work with. Then, if there's any constant, such as A or C, as the case may be, treat it as 0. But here I don't have any constant, so there's no need to check this box. Confidence level, you might want to check it if you wish to. That is, if you understand what it does. And what does it do? Confidence level is like a benchmark, a hallmark, a landmark to you accepting or rejecting the null hypothesis. Now, it includes the time whereby you say, I'm 99% confident that this analysis will not fail because I have taken my time to run a lot of tests on it and I'm very sure it will not fail. It's just like also telling you that this machine you are using or this is like 90% efficient because nothing in this world made by a man is 100% efficient. So you might want to choose your confidence level to test out the level of confidence you have that the results you are going to partake in will either reject or accept the null hypothesis. So my usual case, I normally love to check the box of confidence level, and this will be active, telling me that by default what is given here is 95%, which is equivalent to 5% level of confidence. So I can leave it as it is, or I change it to 90%, which is equivalent to 10% of confidence level. So either cases, I'm good to go. After leaving these two labels, these two check boxes, I'll come down to output options. First, I'll just scroll down to residual. Remember when we discussed about residuals, where we said that residuals are those errors that can come up, that the leftovers when your analysis is being done. So I want to check the residuals, but I don't want to just check residuals. I want to check both standardized residuals. Now, why? Because standardized residuals are residuals that follows the normal probability or normal distribution. And that normal distribution, I will show us what it looks like before the class ends today. So since I'm choosing standardized residual plots, I should choose a line fit residual plot to support my standardized residuals reports or output. Then I don't want to check this normal probability plot because I don't need it. But if you need it in your project, you can want to check it. But for a starter, we work with the ones we are working with currently. Then lastly, output options. Where do you want your data to be located? Where do you want it to come out? By default, it was a new worksheet flag. That means the result of what we are doing now, we open a new sheet by default and show us the answer. But that's not what we want. What we want is the answer should be in this same sheet we are working with. To achieve that, we click on output range and then click on the box beside it. It must be active before you choose a range. So let's scroll down to choose a range and we want the results to come and just come somewhere here. So when I click on this cell, automatically it's pop up in this box, showing that I have referenced this cell to be the cell I want as my output range. Now all these are good to go for me. We are now ready to allow Excel to run the analysis for us. Remember, the y-axis or the y-range is the exam score, which is dependent on the hours of study, C range. Having achieved this, we are good to go to run our test. So let's just click one button and we are good. We click on OK. Excel will run the analysis for you immediately. Now look at the analysis result it has for us in this regard. The multiple R square, adjusted R square, standard error, observations, regression, residual, ANOVA. So look at the regression we are talking about here. This guy here is our main focus, regression, because there's no how you run regression in any statistical package. You will not see ANOVA. ANOVA must follow it because ANOVA and regression works together. ANOVA is a bit similar to regression, and they cannot leave each other. So here we see the regression analysis we have run, and we said that regression is us modeling relationship between two or more variables, which include dependent variable and or independent variables. So the relationship between them is what we are going to look into. And our main focus is in the adjusted R. Our main focus is on the adjusted R. That's how tells us the actual relationship that occurs between the hours of study and the exam score. And notice again that our alpha, which we are in here, was 0.05 or 5 points, which is also a p-value. And whenever it is above that, we always reject the null hypothesis because that is actually the syntax of focus. Whenever the calculated F is greater than the significance F, we reject null hypothesis. When it comes to ANOVA, then for regression, since p-value is always at 0.05, and if the regression value we get is above it, we conclude that we are going to reject the null hypothesis and accept the alternate hypothesis. Now, notice the relationship between these particular parameters, 0.976 to 6374, which means that the relationship that we have modeled between the hours of study and exam score is a very strong positive relationship. If you are to run this in a percentage, it will be 97.63% or 97.626%. And the relationship is a very near and straight cut one because over here you can see that we have all we need to know about the data set. Our focus, like I said, in regression analysis is on the adjusted R. It is actually the place that tells us the relationship we have modeled. How strong is it? How weak is it? Is it a negative relationship? A positive relationship? This is where we find it all, right? And this adjusted R is gotten from the multiple R. So when the multiple R is gotten, which is the correlation between the data points, it is being squared to get this, then also adjusted to get this. So that's why this is our last bus stop whenever it comes to working with Excel regression analysis, whether it's Excel or is it in any other statistical package such as SPSS, Matplotlib, SPSS R or Lingo, not Lingo, SPSS R or MATLAB, far aside every other statistical tool you can think of. So here we have seen that this 0.9762637 is greater than our alpha, or which is 0.09, our p-value, which is 0.05. We have seen that 0.9762637 is greater than 0.05. Hence, we conclude this way. So this is how you run conclusion statistical analysis. Let's put conclusion. You say, since the adjusted okay, let's say since the p-value, let's use this word rather, since the p-value at 0.05 is less than the regression value, comma, we reject the null hypothesis. right? But we say, sometimes you can say, since the regression value is greater than the p-value, we not accept the H0. So either cases that works best for you, no problem. Now what we derived, we have used regression analysis to see that there is actually an effect that comes when one studies well or in a larger extent of data, large extent of study compared to when the person studies in a small or little extent. That's what it means. And by default, you can see that below physically. Someone that studied for 4 hours scored 60 in exam score. By someone that studied for 20 hours scored 95 in exam score. So there is a lot of impacts, a lot of effects hours of study have on exam score, which we just saw in this particular analysis we have made. On our next class next week, we are going to discuss this ANOVA. What is this ANOVA? Why is it here? What is it doing? We're also going to discuss this residual outputs, which always come from the this E on our formula here is what we call what error or residual, or most times call it residual outputs, right? And it must be in your regression. What does it do, and why are we having residuals? We are going to see them on Tuesday next week to see how we can explain it to a little stakeholder, as the case may be. And another proof that what we concluded was correct was this ANOVA table. Notice the p-value is minus 0.0000000000000 up to what 20. Then you get the formula by here. You're seeing 1.6822411722035078 exponential minus 20. That means there's about 19 zeros before we get the first digit to 1. Right? So since the p-value for this is very low on this particular regard, we will have to reject what? The null hypothesis if we are to use the ANOVA. Right? If you are to use the ANOVA to decide, p-value must be less than 0.05 for it to be significant. That means it must be less than 0.05 for us to reject the null hypothesis. But when it's above, we are going to accept in this particular regard of analysis of variance, that's ANOVA. Likewise, the same p-value for the hour of study, which is the bx. Why this for the b0 intercepts? So you see that even though we don't want to use this particular adjusted R here to put our decision, the result from the p-values of the ANOVA that follow the regression has given us an insight that since the p-value is less than 0.05, they say that we can reject the H0 and conclude that there is an effect on exam score by the hours of study. So this is how you conduct this wonderful statistical test called regression analysis. You see how we have combined our knowledge of hypothesis testing with regression analysis. There is one more analysis we are going to run regression, which we are going to see on the next day of class. And that analysis is the chi-square test. We are going to see how we can use chi-square test on this actual data of choice, which is this data here. Also, we can use chi-square test on this if it is possible. But if it's not possible, we will use a test to run it, or another data, sorry, to run it. But after we have studied it and understood what chi-square test is and how it is used for in analysis, and also have understood the concept of chi-square, we might decide whether we are going to use this particular dummy data or not, or we create our own dummy data and use it for what? Chi-square distribution analytical tests. So don't mind the chart we have here. So this is the chart we have here for a normal probability. Remember that we said that regression is used to model relationship, and there's no better test to use to do modeling and prediction in data science and data industry aside of regression. So most of the prediction you see happen in the data science space is being done with regression analysis. If it's not normal simple linear regression, it will be ordinary linear regression. It might be geometric linear regression. It might be logistical regression, or ordinal or nominal. Any of these regressions can be used to run a modeling, which is also being used to predict what is happening. And look at what this chart is telling us about hours of studied line fit plot, just like we clicked on it. After you click on that standardized, which is what we have here, the standardized residual, right, gave birth to hours of studied line fit plot, showing us that if you are to predict the exam score of these students, it is still on the average of the more hour you read, the more you score well. The more hour you read, the more you score, from what we are seeing on this chart. So there's a lot to discuss about the output of this regression we just did. And I'd like you to sit tight and wait for it to come the next day of class, where we digest what is happening in this handover. What is this DF, SS, MS, F, significance F? What is intercepts, hours of study, coefficients, standard error, t-test? So what are they doing here, and how do they impact our insight from analysis? We see that comes to place. If you have a question, kindly ask questions. We are free to answer you. Please, if you have a question, you can ask.
Good evening. There's no question, but I would really appreciate if this one can be uploaded quickly, because it really needs looking at again for proper
Right.
understanding.
No problem.
Yes, sir.
I'll let the person in charge to know that it needs to be uploaded as quickly as possible. And like I told us, please put your notification bell on that particular channel, so that once it is being uploaded, you can get notified. I always do get notifications so that you don't miss out on any section, please. Very, very important.
Okay, sir. Okay, sir.
Thanks. So thank you very much. After you must have submitted the assignments due on Tuesday. You have that phone, I trust.
Okay, sir. Bye-bye.